Okay, so it's 10 o'clock, and I think we're just going to kick it off. So, thank you again, everyone. I know it's Sunday morning on DEF CON, last day, so I really appreciate you guys being here, and I'm hoping this is a useful one for you guys as well. Quick introduction. I'm Eugene. I go by Space Raccoon Online, and this talk is Escaping the Privacy Sandbox, Deep Dive Edition. So on Thursday, I kind of talked through some of these findings in the main stage, but I thought this was a good opportunity to kind of break it down a bit more, deep dive into some of the techniques and the ideas I had while researching this topic, and give you a bit of insight into the Privacy Sandbox, which is Google's own ad technology that they're trying to use to replace third-party cookies. So just a quick check, did anyone kind of catch the talk on Thursday? Great, okay. So this will be hopefully new to everyone and give you guys a bit more information. So quick introduction, I go by Space Raccoon Online, and that's my hacker handle. In my day job, I do security engineering. I work with a team. We just kind of do cybersecurity, but in my night kind of hobby, I do love vulnerability research. So I do a lot of hacking. My most recent kind of research I did was on smart weighing scales that are connected to the internet. And that seems like a very common theme where why on earth would you connect that to the internet? So that's kind of my hobby. And this is one of those research projects that became pretty interesting. So, quick context, cookies are on their way out. You might have seen this in headlines. You might have seen that really annoying pop-up you get when you visit websites and they're like, do you allow all cookies? Do you just accept necessary cookies, or do you decline for all of them? And the whole kind of background to that is that more and more browsers are starting to phase out third-party cookies. And third-party cookies are something a lot of advertising technology uses to keep track of you, pretty much, to make profiles about your interests, your likes and dislikes, and to show you ads that hopefully you will be more likely to click on. The other side of that is also they use that to keep track and of the conversion rates of ads. So maybe you see an ad on one website, and then maybe 5 days later you visit the website and you buy something. They're still able to track some of that activity, both using third-party cookies, but also all of these additional APIs that is part of this whole ad technology apparatus. So I think for me, one of the biggest things and the biggest changes has been legislation. You see a lot of the legislation that is reducing the amount that companies can collect about you, but this has also meant that companies are looking for alternatives to third-party cookies to still get this information. So one of the things that you do see is also that consumers are getting smarter. You and I, we get ad block extensions, we are adding, pie holes into our network, and that is also reducing the effectiveness of third-party cookies for advertising technology. But I kind of want to address the elephant in the room, and I think the CPV committee actually pointed this out to me, was that very conveniently after around the time I had submitted this talk, Google actually announced that they were no longer going to phase out third-party cookies. So originally in 2022, they kind of made this big announcement that they were going to phase out third-party cookies entirely and replace it with their own technology, which is the Privacy Sandbox APIs. But every year they kind of said, okay, we'll do it next year, and the next. And basically this year they kind of gave up and said, we're not going to phase out third-party cookies. But I think, that's still not a reason for us to stop looking into this. Why we still care is firstly, obviously, is that it's still in use today. Chrome and Chromium browsers are loaded with the Privacy Sandbox technology. It's good to understand what's going on because it's actually, if you actually just go into your Chrome debug tab for Attribution API or any of the other Privacy Sandbox API, you're going to see a lot of interesting information that is being tracked about you right now. The second thing is that because advertising companies are still using it. It's not just Google that is using it for their double-click ad platform. You see a lot of this information and this technology still being used by all the other big ad tech platforms out there, like Criteo, even Facebook, Amazon. All of these companies use this privacy API as well. And the third is just that it's interesting. One of the things that I kind of came across while doing this research is that ad technology companies don't really want you to understand ad technology. There is not a lot of documentation. A lot of this technology is opaque to you. And there is a lot of information collected about you in various ways. And in this case, I think it's good to understand how Google tried to design a privacy-preserving ad technology. I know it sounds like a complete contradiction because how do you do that? And to kind of get inspiration for that, but also look at the pitfalls, right? When they're trying to satisfy both advertisers and privacy rights, it's not going to work out. There's something's got to give. And there are some of these things that led to the issues that I discovered. So let's kind of dive into the Privacy Sandbox, right? What makes up the Privacy Sandbox? So the first part is that Google has added a bunch of experimental JavaScript APIs to Chrome and Chromium. So these APIs are only available on Chrome and Chromium browsers. Firefox has refused to add them. Safari has not added them. So you'll see them in a lot of Chromium browsers, including Edge, for example, which still gives it a lot of distribution. The second thing is that Privacy Sandbox is a walled garden, which is kind of the theme of the Privacy Village this year, which is in the garden. And this garden essentially means you have to apply to Google to be given access to the Privacy Sandbox and to be able to use the Privacy Sandbox APIs. Now, there's some question here about verification and does this give Google a bit too much power? I think these are things that all the kind of marketing and ad tech platforms have kind of looked into. And the last thing is pretty interesting, is that Google has something that what they call a trusted execution environment that you can load into your own cloud accounts as a ad tech company. And this allows you to then pull and decrypt aggregated analytic data from Google servers itself. And this is also pretty interesting because the idea is that you don't have direct access to all of this aggregate data, but you are able to perform some sort of analysis on this data in the trusted execution environment. Now, the question is this really that hidden, even because you're running it on your own cloud account? But this is not really the focus for today's talk. I'm just going to focus on the first part, which is those JavaScript APIs and client-side attacks. So for today, I think I'm just going to focus and deep dive into one particular angle of research, which is the Attribution API. And so what is the Attribution API? So one day I was kind of looking for things to hack. And one of the things I like to look at is actually the MDN documentation on all the JavaScript APIs. So this is kind of what the page looks like. And I saw this weird looking Attribution API link. It has that experimental test tube icon beside it. And that's usually a good place to find something weird because this means that this is experimental, the kinks have not always been worked out, and there might be security issues as well. So when I looked into it, I began to understand that this was part of the Privacy Sandbox. And what this function does, what it serves, is that it solves one simple and very common problem in advertising technology, which is checking if when you view one ad on one website and you eventually bought something or you kind of went to the website that was being advertised, this counts as a conversion. This is really simple to do using third-party cookies, but the way that's implemented in the Attribution API is way more complex because they want to have that privacy-preserving feature. So I'm just going to kind of break this down for you guys. So the first part is registering a source. Say you go visit a website, a news website that shows an ad to you. On your browser side, this is a call to a HTML element that has the attribution source attribute or a XML HTTP request that includes the attribution source option. Now, a browser that supports the Attribution API will then make an async call back to the ad tech server asking, hey, this guy viewed an ad. Can you just tell me what this ad, give me some information about this ad so I can track a conversion later. And what the ad tech platform does is that it responds with a header with additional information about the ad. For example, what was the intended destination after you had viewed that ad? So just a quick breakdown, this is what the HTTP request looks like. On the left is the request, on the right is the response. What you'll see in the response here is you'll see a JSON string that includes, for example, the intended destination of that ad that's being viewed. And this JSON string is then stored in your Chrome storage for future reference. So what's step two? Step two is the conversion. So ideally, maybe you viewed the ad and you clicked on the ad, or maybe you went back later and bought something, went to the website and bought the ad. When you perform that conversion action, which could be anything, you could be watching a video, you could be making a purchase, or you could just be visiting the website. Then a second request is sent by a browser, again using the attribution source attribute/option that will request a trigger. And the ad tech server would then respond with more of the trigger information that will allow the browser to then perform a check. Before I go into the check, again, we're just going to look at the HTTP requests that are sent. So again, on the left is the request, on the right is the response. You would notice that in the response header, there's a set of filters. This allows the ad tech or the ad to, again, filter by specific features of the ad. So for example, you visit the website and you maybe watched an ad that was selling you flights to Peru, but you went to the website and you bought flights to, I don't know, Singapore, right, which is where I'm from. And that filter would then allow that trigger to be specific to that item that you purchased, just as an example. So once you have these two pieces of information that, again, your browser is completely handling async, it is not something that's done injected in the context of the site itself, it's done by the browser. What happens then is a matching occurs. So your browser is going to check the trigger that came in and match it among any of the stored sources that have been created in the past in your browser storage. And you'll use items like the filter to further narrow down the search. So it may be intended that the ad does a specific conversion and not any other kind of purchase. So they're not going to count that as a conversion. And that will allow that to be more specific. And once that is done, a match has been found saying that, hey, this ad was pretty successful. You saw that ad and you bought something. It will send an event report to the ad tech server confirming that this occurred. So once again, this is something that you see with the request and response with the ad tech server, in this case, Google AdSense, double click. And you see, hey, this person watched this ad, this was the intended destination, and it was successful. Again, this is sent by the context of the browser and not within the site that you're viewing itself, which leads to certain interesting behavior, which I'll discuss very shortly. Now, because this is kind of like a deep dive, I just wanted to show you a bit more about like what I was doing spelunking to trying to figure out this whole thing out. The documentation was good, but still very broad, and there was not really a lot of information to give me a foothold. So one of the ways that I used it to observe this was just this Chrome debug tab, and all of you guys can probably access that if you're using a Chrome or Chromium browser. Just go to that tab, and then in another tab, just visit a news website or anywhere that serves ads, and you start to see a lot of interesting information come in. And if you look at the fields that are being stored as well, there's a lot of interesting information that they're capturing about you and is stored on the browser. For example, in this case, you look at a source registration. I visited theverge.com last night, and you would see the reporting origin, the destination, a number of aggregation keys, and a debug key. These are all ways that they can use to identify your session unique to you. And I'll go more into how this kind of leads to other problems with the privacy preserving features. Another way that I kind of inspected this was just keeping a record of all the requests sent by my browser and then looking for that specific attribution reporting request headers and responses. This gives you, again, a lot of information because, as I mentioned earlier, while this is a Google technology, a lot of other platforms are still using it. You see, for example, Taboola, you see Quora, Facebook, LinkedIn. All of these websites and companies are still leveraging this Privacy Sandbox API. And again, this is a convenient workaround in the case of third-party cookies, especially because they're so highly regulated these days, to still have these tracking features on you without, you might feel safe because you declined all of those cookies, but now they can still keep track of you through these various APIs. And this is, of course, very useful to ad tech companies. But let's kind of zoom back a bit and kind of say why this is supposed to be better than third-party cookies. Well, the first reason why is that it is somewhat randomized. So Google has built in some randomization in how often these requests are sent so that you can't specifically identify a specific session to an individual. The second is that it's fairly limited. The kind of information that can be captured that is allowed as part of the Attribution Reporting API schema is, again, fairly limited to numbers or integers or debug keys. So ideally, not that much information is actually captured with you. And again, there are some rate limits as well to further limit the amount of information that can be captured for any particular individual. And the last thing is that it's somewhat noisy. So they add noise deliberately, statistically, so that while on the aggregate, the kind of analytic data that companies are getting is accurate, but for any individual data point, there is some ambiguity or noise, right, that ideally masks individuals' browsing activity. So these are kind of the attempts at making this better than third-party cookies. So one of the ways that I kind of started looking into this was that actually the Privacy Sandbox is pretty well documented. So they have a GitHub account. In this case, they do have a number of projects, and there's a lot of interesting issues that you can kind of read the discussions and understand the thought process that went into designing the Privacy Sandbox. One of the interesting repos that I looked at was the attestation repo. And what they kind of published there is a very infrequently updated list of everyone who has ever signed up with the Attribution Reporting API. And this was fairly eye-opening. You can kind of see the list of companies listed here is in the hundreds. And one of the ways I did use this data was then to basically iterate through every single one of them to check their attestation file that they have to make publicly available as part of the Privacy Sandbox. But really kind of the takeaway from this was that I was trying to look for takeovers to get into this walled garden in the case that I was not able to register myself, and also better understand this entire landscape. There are a lot of weird companies out there that do like ad data broker technology, and this kind of transparency kind of makes it easier to understand what's going on here. But actually, it's fairly easy to sign up for the Privacy Sandbox itself, or at least before, I don't know, it was like a few months ago. Google did allow you to sign up as an individual, but they have blocked that, and they have also suspended my account. So, I mean, I did tell them of the issue, so maybe they were, pretty responsive to that. So when I first started on this research, it was this jank Google form, and then you kind of submitted it and hope for the best, and a few days later, someone would email you, be like, hey, welcome to the Privacy Sandbox. But now they've kind of moved on, and they have this proper, Privacy Sandbox console. I think you do have to provide a valid TIN number, which is a company number, but I'm not sure if that's still the case. And basically, there's some level of validation that goes on before you're added to the Privacy Sandbox. Now, this is really, really important because your website needs to be on this Privacy Sandbox whitelist before it can be a attribution source, the callbacks that were happening. If you're not on that list, Chrome or Chromium browsers will block your site from being a callback destination. So this is kind of the first start. And I was able to get in that way by kind of saying I was a company. I am not a company, and I do not have a company, but they still kind of put you in this walled garden. Another kind of interesting piece of information is that their GitHub documentation is pretty good. So they have two sets of documentation. They have the kind of corporate-facing public on their own website documentation of the Privacy Sandbox APIs, walks you through it. But interestingly, I found that the GitHub documentation had a lot of data that was not reflected in the other website, the corporate website. It gave me interesting information, and if you look at that little to-do there, it also gave me hints about where I might want to poke at for issues and discover problems in this implementation. So this brings me to the first kind of attack, right? Which is attribution reporting debug reports. So one common characteristic of the Privacy Sandbox is that they're trying to satisfy multiple parties. They're trying to give advertising platforms, the data they need, but they're still trying to maintain privacy. And one of the ways they try to bridge this gap is building this escape hatch, which is the debug report. And as you can see in the documentation, they say it's transitional and it's temporary and it's going to only last until they phase out third-party cookies. But as we all know, they're no longer phasing out third-party cookies, so it's far less temporary than I think they expected it to be. And the reason why it's temporary is that it actually leaks additional data, information. In this case, debug information about where this data was captured or where a conversion was recorded. And the reason why this is important, if you go back to the to-do, they said, consider adding support for top-level sites to opt into receiving debug reports without cross-site leak. So this is an issue. What is a cross-site leak? On your website, you can kind of load third-party resources from other origins. And one typical way you might want to mask this information through the referrer header. So say you're website A and you're loading an image from website B. Website B could technically know where their image was being loaded, what website A is about, because of the referrer header. And one typical way to mitigate this is through the no referrer tag. As you can see on the left, the referrer policy, no referrer. But Attribution Reporting API through the debug reports bypasses this mitigation. Now, there might be something to be said here about how referrer header was not meant to be like a foolproof protection. It kind of evolved as the web evolved. But the key thing to understand here is that there are a number of platforms and technologies that are based on this assumption. So I went out and wanted to start testing this, and The way that you actually execute the Attribution API is through custom HTML and JavaScript. And one of the changes that I've seen in the ad tech industry is that nowadays a lot of ad platforms are a lot more careful about letting you load arbitrary HTML and JavaScript in their ads. You might have seen those really annoying ads where you can like click a game or there's videos playing. Those are essentially ads that allow advertisers or people buying ads to load whatever HTML they want. And these days, are a lot more careful because this is essentially potentially a Trojan that is being served to all your ads, customers and viewers. In this case, there's a lot of barriers that are put in place. You got to spend at least $10,000 and so on and so forth. I didn't want to spend $10,000, so I found a way around it. So for Google Ads, I think they have this desktop software that allows you to upload like HTML images. This is not available in the Google Ads interface on the web, but you can access it through the desktop. And with that, you're now able to upload HTML5 ads. Otherwise, I think you got to spend like $10,000 or something. But I was able to get it out like that. There's additional information here as well, is that most companies are pretty good about sanitizing this HTML that's uploaded. They don't let you load arbitrary like remote resources, for example. But attribution source potentially bypasses that, right? Because it still triggers a third-party request, but it is not necessarily something that a very naive sanitizer would catch. Yeah, so in this case, I mentioned there's some background here in that you might have issues with bypassing existing technologies, and one of these technologies is SafeFrame, right? SafeFrame is essentially an iframe standard that advertisers can use to put ads inside. And the idea is that because this iframe is pretty hardened, whatever JavaScript or HTML you load in there technically can't compromise the top-level site that is displaying the ad. And one of the kind of mitigations it's meant to do is not to leak the top-level site. But because we have this attribution API, I was then able to bypass this for a few implementations. So I think the takeaway here is that it's hard to understand what kind of things are going to go wrong once you change the fundamental assumptions of how an ad is supposed to be displayed. Okay, so I'm going to kind of skip ahead because time is pretty quick. So this one's an interesting attack, which is destination hijacking. So as mentioned, I was just like browsing, trying to figure out what requests were being sent as part of the advertising that I was being shown. And one day I kind of like realized that all Google DoubleClick ads were injecting additional destinations. So say you viewed an ad for SEMrush on TheVerge.com, and the destination ideally should be SEMrush.com. But Google DoubleClick ads were also injecting 2 additional destinations, potential destinations that could lead to a conversion. In this case, it was debugconversion1.com and debugconversion2.com. Now, do you want to guess what the problem is with those domains? Yeah, I could buy them for like $10, right? And this was literally every single ad served by Google DoubleClick, as far as I could tell, obviously. And so I bought them. Now, the problem was like, okay, what can I do with them, right? I can commit ad fraud, right, by fake conversions, which I guess some people will be very happy with making money, but to me, that wasn't super interesting. I wanted to violate privacy. So one of the things I looked into was abusing their rate limits and to get an oracle out of it. Privacy Sandbox API has a lot of rate limits built into them for good reason, because they don't want you to collect too much information about individual, as I mentioned at the start of this presentation. But I found an undocumented rate limit where you could only send reports for specific destinations for up to 1,000. What this meant was that now I was able to create a Boolean oracle to determine if someone had visited a website or not. So if we go back to the case where they perform a conversion at the original correct website and not the debug conversion website, this would send one conversion report. In this case, there'll only be 999 reports left in the rate limit that could be sent. So if they visited my attacker website afterwards, I would then be able to then send 999 reports to debug conversion domain 1 or 2.com, which I control. And because they had already visited or performed a conversion action, I would be able to tell that was the case. And as you may recall, I mentioned filters, other ways that I could use to filter this information further. I could then be very specific about the information I wanted to extract about a person's previous activity or history. Now, in the case that they didn't visit that website or didn't perform the conversion action, then naturally I'll be able to send 1,000 reports in total, and this will kind of work as a Boolean oracle. So yeah, I think this was an interesting way that I was able to achieve de-anonymization of a user. This is typically information that is not meant to be shared with a person buying an ad. Say, X individual from Y IP address visited Z website in the past. But because of this oracle, I was then able to achieve this and de-anonymize a user's browsing history. So yeah, I think there's still a lot more. There is some weird stuff that you see injected. I do encourage you to look into your Chrome browser debug console and see what else is being injected. But I want to summarize the bigger picture here. First is that privacy preserving ad tech is not just an oxymoron, it's really, really hard. There are a lot of assumptions that are being undermined once you add that kind of technology with legacy and classic mitigations. And the second thing is that the attack surface is large, right? It keeps expanding. And so I kind of want to leave you on that note. There's still a lot more to be researched. I think ad technology, as mentioned, they don't want you to kind of know too much about it, but security researchers, I think, may not have paid too much attention to it. And there is a lot of interesting data because this is, a large majority of our internet is unfortunately taken up by advertising, and it makes a lot of money out there. So yeah, I think that is all I have for this talk, and thank you for your attention.